We have this polar function, r of theta equals sine theta, and we're asked to graph it. We should recognize that r of theta is the same as r, so don't get intimidated by this r of theta, just change it to r. And I added some ones and zeros, and we're going to use that to graph this function in a moment. But I want to talk about polar functions in general. Polar functions are just another way to identify the location of a point. So let's say we had this point in space right here. Well, we know that we can identify that point on the rectangular or Cartesian coordinate system using x comma y. So if we say this x is about 3 and this x is about 5, we can identify that point as 3 comma 5. But folks, there's another way to identify the location of that point, and that is to use polar functions. So here, imagine someone sitting right here at the origin, otherwise known as the pole, as in North Pole, and throwing an object this distance r, like so. And then we have to identify at what angle was that object thrown. In other words, was the object thrown at distance r this way, here, this way? So we need to specify what was the angle at which that object was thrown from the pole. And the way we do that is we establish this, the x-axis, as the baseline, and we designate an angle theta. So it's another way to locate a point using r theta. And as you'll see, we're going to be using concentric rings with a radius of r to identify points as we change the theta angle. Now folks, another way to think about polar coordinates is this diagram here. Here's the intuition. So you have a person standing on the North Pole, there's the pole, the origin, and if he or she throws an object downwards, it would be a distance r and it would be at an angle of theta. So again, here's your man or woman sitting on the North Pole throwing an object r at an angle of theta. Folks, when I graph polar equations, the first thing I do is graph this as if the function was y equals sine of 3x, where x is down here and y is here. So the y value, the output, is going to be your r value, and the x is going to be your theta. So if we were to graph this function on the rectangular coordinate system, we would recognize the following. First of all, we have a sine graph. That means it starts at its midline. We could see here that the midline is 0, so let's go ahead and draw that in. Since this value right here is 1, that's our amplitude, that means our minimum and maximum values are going to be positive 1 and negative 1. Since our graph starts at the origin for sine, we're going to have something like this. It's going to jump from the midline to the maximum, to the midline, to the minimum, to the midline. Okay, so let's look now in this portion of the function, the inside of the function. The fact that that's a plus 0 means there's no phase shift. So our starting point is going to be, as mentioned, the origin. Now that 3 right there is going to determine the period. Now normally the period for sine is 2 pi. However, we're going to take the period, which is 2 pi, and divide it by the absolute value of that 3. So the period of this function is going to be 2 pi over 3. And the way I think of it is if I see a 3 with a trigonometric function right there, that means everything's going to happen faster, 3 times as fast. So if the normal sine function does that and takes 2 pi to do it, this guy's going to go quicker, like that. Okay, so the next thing I like to do with trigonometric functions is we know that the starting point is 0 and the ending point is 2 pi over 3. So I like to divide into 4 parts. And each of these tick marks is going to be 1/4 of that period. So how do we get 1/4 of the period? We take 2 pi over 3 and we multiply by 1/4, and we get 2 pi over 12, otherwise known as pi over 6. Now, because we're in the world of sixes for each fourth of a period, I'm going to change that to 4 pi over 6. And if your teachers don't like that, you can just go ahead and at the very end go back and reduce all of these fractions. Okay, so we're going to start at 0. This is going to be pi over 6. This is 1/4 of the period. How did we get that? We multiplied 1/4 times the period. So that's 1 pi over 6. This is 2 pi over 6, 3 pi over 6. We are marching by 1/4 of the period. Okay, so now folks, we're going to go ahead and graph. We're going to start at 0. We're going to go to our maximum 1/4 of a period later. Then we're going to be at the midline. Then we're going to be at the minimum. Then we're going to be at the midline. So this is our sine function. And we are going to use these values to graph this on the polar coordinate system. Let's now go ahead and graph r equals sine of 3 theta with the help of our rectangular coordinate graph. Okay, so here we're going to start when theta equals 0, and when theta equals 0, we see that the r value is 0. Again, the y value on the rectangular system is going to be the r value on our polar system. So right at theta equals 0, we're going to be at r equals 0. So our first point is going to be right here at the pole. Okay, our second point now, we're going to move from 0 to pi over 6. So we're going to be in this section from theta equals 0 to theta equals pi over 6. Now, when theta goes from 0 to pi over 6, we see that the y value goes from 0 to its maximum at 1. So this is now going to be a point right here. So let's draw this within the section between 0 and pi over 6, right there. We are in this section. Therefore, the graph has to be between 0 and pi over 6. I say that because you want to avoid doing this to get to a y value or r value of 1. Because this dotted graph is in between the section of pi over 6 and 2 pi over 6. But that's not what this first move is. This first move is between 0 and pi over 6, so we're going to stay in that section. So let's go ahead and erase the white dotted line. Okay, our next move on the rectangular system is an r value of 1 at pi over 6 to an r value of 0 at 2 pi over 6. Okay, so we're going to work in this section right here between pi over 6 and 2 pi over 6. And we're going to take this r value and it's going to go back to the midline, which in this case is 0. So there's our first petal. And I forgot to mention, we will have 3 petals because that value right in front of the theta is odd. When it's odd, we'll put it this way. If you have sine of n theta, then the number of petals, if that n is odd, is going to be n. However, if n is even, then the number of petals is going to be 2n. So for example, if we had sine of 2 theta, we would end up with 4 petals. Okay, so we may have to go further. we may have to go more than one period to get our 3 petals. Okay, let's keep moving. So now, this is very interesting. Now we are moving from 2 pi over 6 to 3 pi over 6. That's this section right there. And during that movement, the r value, which again is the same as the y value here, goes from 0 to -1. Okay, so now the problem is, or the issue is, that we see that we are below the x-axis during that period. This is negative. So so instead of being in this section right here, we are now going to be in this section. We're going to come through the pole, just like we were dealing with a vertical angle. And this is its sister section right there. That's where we're going to be, because that is negative during this step from 2 pi to 3 over 6. So notice, folks, these are vertical angles, so to speak. Right? So you're going to go there to there. What you're not going to do is come to this section or that section. You're going to go straight through. Look at this. If I change those to red, that's where the sister section is. Vertical angles. Okay. So now we know we're going to be in the sister section down here. So let's go ahead and erase what we have up here and see what we're going to do. Okay, we are going to move from a value of r equals 0 to r equals 1, and we're going to do it in that section. So we're going to go ahead and take our graph from 0 to 1. Okay, I forgot to mention that is +1, -1, -1, +1. Okay, so that tells us when we're moving to -1, we don't go in this section, we go in that section. The sister section of where it would be, since we're moving from 2 pi over 6 to 3 pi over 6. Okay, now we're going to move from 3 pi over 6 to 4 pi over 6. Okay, that would normally be in this section right here. But because as we're moving from 3 pi over 6 to 4 pi over 6, we are negative, that means we're going to use the sister section. All right, so let's look at where the sister section of that green location is. We're going to come right through, and it's going to be right there where that red is. This red section and that green asterisk are sister sections. Okay, so let's see what happens during that time. We go from -1 to a value of 0. So that means we're going to go from -1 to 0 within that sister section, like so. Now, folks, we are now at 4 pi over 6, and we only have 2 petals. So it seems to me we're going to have to go a little bit further. So let's go ahead and extend this rectangular graph a little further beyond the first period. Okay, I went ahead and extended our graph on the rectangular system another period. Okay, so we left off at 4 pi over 6. That was this section over here. Between 3 pi over 6 and 4 pi over 6, we should have been in this section. But because we were negative on our graph, we went to the sister section and came from -1 back to 0. Okay, so now look what's happening between 4 pi over 6 and 5 pi over 6. That's this section right here. So that's where our graph should be, as long as we're not negative, and we are not negative. You see we're above the x-axis, so we're going to graph in that section. Okay, in that section we go from the midline, which is 0, up to 1. So let's go ahead and do that, like so. And we know folks, that we don't go this way to get to 1. Why? Because we are in the section between 4 pi over 6 and 5 pi over 6. We are in this section. So our graph should be here, not here. That's how you know which way to draw your curve. Okay, finally, we are now moving between 5 pi over 6 and 6 pi over 6. This is our section. We are going to stay here. Why are we going to stay here? Because this graph is above the x-axis. If for whatever reason this move occurred when r was negative, we would come down to the sister section, which is the vertical angle coming right through the pole. This is where we would be graphing. Okay. Actually, my mistake. This is the section between 5 pi over 6 and 6 pi over 6. I apologize. If for whatever reason this was negative, we would be graphing in this sister location right here. We would go right through the pole to get to here. But because we are positive between 5 pi over 6 and 6 pi over 6, we're going to stay in our section, and we're going to take our r value from positive 1 back down to the midline, which is 0, and now we have our 3 petals. It did take 1.5 periods to graph it. Folks, when you have rose petal graphs, they're going to look like this. R equals a cosine of n theta, or r equals a sine of n theta. This a value refers to how long each petal is going to be. So in other words, this distance from the pole to the end of the petal. The n value tells you how many petals there are. If n is odd, you're going to have n petals. It's going to be what you see. However, if n is even, you're going to have 2n petals. Finally, of note is that when you have a cosine graph, that is going to be symmetric over the x-axis. So cosine is going to be symmetric over the x-axis, and sine is going to be symmetric over the y-axis. Okay, let's take a look at what we just did and compare it to what we just discussed. So here is r equals sine of 3 theta, so the r value here is a hidden 1. Therefore, that is the length of the petals. And that's what we see here. We see that the length of each petal is 1. That's our value of 1. We also see that because the n value, which tells us the number of petals, is odd, you keep it as you see it. So there should be 3 petals, and indeed we have 3 petals. And finally, since it's a sine graph, it's going to be symmetric over the y-axis. So if we look at this as the y-axis, you could see that this graph is symmetric over the y-axis. Next, we are asked to graph this polar function, r equals 2 sine of 2 theta. So based on what we just discussed, that indicates that the length of each petal is going to be 2. That's why I went ahead and have 2 concentric circles here. This is a distance of 2. So our petals are going to come all the way out to 2. We have a sine graph, which means it's going to be symmetric over the y-axis. Our n value is 2, and because that's even, we're going to end up with 4 petals. So that's the intuition. Let's go ahead and graph this, and I went ahead and did that. This is the rectangular graph, y equals 2 sine of 2x. Okay, so here we go. Our starting point, when x equals 0, the r value is 0. So x equals 0 is going to be right here on the polar axis, and our r value is going to be 0. So the first point right there is located at the pole. So if this is point A, that would be point A right there. Okay, so the next thing we're doing is we're moving in the section from where x equals 0 or theta equals 0 up to theta equals pi over 4. So this is the section of the next portion of the polar graph. Now, as we see, we are positive here. That means our graph is going to stay in our section. And as we move from theta equals 0 to theta equals pi over 4, we see that the length of the graph, the R length, increases from 0 to 2. So that means we're going to do this on our polar graph. Again, that's a 2. We started at 0. How do we know we're not going to go over here? The answer is that graph would be between pi over 4 and 2 pi over 4. That would be the wrong section. All right, let's go ahead and erase that, and let's see where we move next. So next, we are going to move from pi over 4 to 2 pi over 4. And we could see that on our rectangular graph, the R value, the Y value, and the R value are synonymous. The R value goes from 2 to 0. So we're going to take this from 2 to 0 during this section, which is pi over 4 to 2 pi over 4. Again, since we're positive, we're going to stay in the appropriate section. Okay, next we're going to move from 2 pi over 4, where the R value is 0, to 3 pi over 4. And the first thing we notice is now we are negative. So between 2 pi over 4 and 3 pi over 4 should be this section here. But because we're negative, we're going to go right through the polar axis, and we're going to be working in this section, the sister section. All right, so let's go ahead and erase this, and let's see how we're going to draw our graph. So here we see from 2 pi over 4 to 3 pi over 4, the graph goes from 0 to a length of 2 in the opposite direction. So since we're here, in this section, we're going to go from a length of 0 to a length of 2. So we're going to have this. So we're going to have this right here. Okay. Next, we're moving from 3 pi over 4 to 4 pi over 4. We should be in this section, but because we're in negative territory, we're going to work in the sister section, which is here, and we're going to go from 2 to 0, like so. Okay, now, folks, we know this is symmetric with respect to the y-axis, so we're tempted just to go ahead and draw the other petals in, but let's go ahead and do it appropriately. All right, so we're now at 4 pi to 5 pi. We are positive, so we're going to stay in the appropriate section. Here's 4 pi to 5 pi. We're going to stay here. And what happens to our R value? It goes from 0 to 2. So we're going to do another petal from 0 to 2, and we're going to stay in our section because we're positive. Next, we're going from 5 pi over 4 to 6 pi over 4. We're positive. We're going from 2 to 0. That's going to be this petal here. Next, from 6 pi over 4 to 7 pi over 4. We should be here. We should be here. Between 6 pi over 4 and 7 pi over 4. We should be in this section, but because we are negative on the rectangular graph, we're going to be in the sister section, which is going to be right through the pole, which goes straight through right there. This is where we're going to be. So let me erase. I got too many asterisks here. This is where we're going to draw the next portion of the graph. So what would have happened between 6 pi over 4 and 7 pi over 4? We see we go from 0 to 2. So we're going to go like this. And then finally, we should be between 7 pi over 4 and 8 pi over 4. Here on the rectangular graph, we're negative. We should be here in green, but because we're negative, we're going to be in the opposite section. We're going to go right through the pole, and we're going to end up here. Okay, what happens? We go from a maximum of 2 back to 0. So we're going to take this and go from 2 to 0 in that final section. Okay, let me erase that and make that red. From 2 to 0. We went from 2 to 0, and this is our graph. 4 petals, symmetric over the y-axis because it's a sine, and that length in front is the length of each petal.